Okay, so today we'll go through LLM agents, some simple concepts, and we'll walk through a code demo as well, and then we'll jump to presentations. So, like we spoke about last time, the way we can think about LLMs is you can use it in many different ways. Um, like you can use it as a simple API call. You can add some structure to it, make it into in-context learning. You can add data sources, and then you can retrieve from that specific data source when you can't fit it in context. You can also fine-tune an LLM model for domain adaptation or for specific business use cases. So that's a LoRa model. We looked at LoRa fine-tuning yesterday, and you also went through a notebook, hopefully. Um, so uh, in context learning, it's great when you can fit everything in context. RAG when you have extra document sources, you want to retrieve from that. LoRa fine tuning, domain adaptation, um, and you can fine tune with fewer examples. Like if you had to do supervised fine tuning with 100,000 examples, you can do LoRa fine tuning with maybe 5,000 examples or even fewer, depending on the domain, and you can get good accuracy. And we saw examples of that for product intent classification yesterday. So today we'll look at agents. What are agents? Agents are LLM systems that can work with tools and a base LLM model to iteratively and in a step-by-step manner reason through information to arrive at an answer. Um, so essentially, there's a base LLM model, or maybe there's more than one LLM model. Maybe you have like a main LLM model, and you have if you have a master worker scenario, you can have a master LLM model that's larger, more accurate, and then you have worker models that are smaller and can do specific tasks really well, or they can address specific domains well. So uh, so you can have a single agent, you can have multiple agents. Um, so a component of an agent is, if you look at a single agent, it'll have a base LLM model and it'll have tools which can be specified in the environment that you're operating in. It can be specified through APIs or function calls. It can be something like as simple as I want to process this text locally, or it can be an API call. It can be something you work with a database. It can be some scripting that's being done locally. So there's a lot of flexibility in how the tools are set up, or the range of tools that you can use with any given agent. And then there is some instructions like basically in the form of a prompt on what to do, how to go about um, responding to a query, and also some instructions on when to terminate. Um, and so you can think of agent as like an abstraction on an LLM, and saying that I want to use some tools and then extract information and be a little bit more automated. So there's with an agent and tools, you don't have to babysit an agent. You don't have to be like, go use this tool and then get some information, then do something else. The agent has the autonomous capability to plan, execute, reflect, and again iterate. So this whole cycle of it's a little bit more autonomous. I would say pretty autonomous once you know that that's the agent you want to use. Um, so when do we use agents? We use agents when the task is complex enough that they need to be broken down into multiple steps, and a single API call of an LLM won't suffice for the task. Right? Sorry, I don't think that works. Multiple displays. Uh, try this. Does this work? Yeah, but then I can't see you guys. Okay, no worries. So a task has to be complex enough that a single API call of an LLM won't suffice for the task. Um, can you think of some tasks that might require agents and won't you won't get a good response with a direct LLM call to a, let's say, GPT-5 model?
Something that's multimodal, I would guess.
Something that's multimodal. Um, like what's an example?
Like you ask ChatGPT, hey, can you generate an image for me? It would probably need to have an agent go off and use another LLM to actually generate the image and then just provides it back.
But do you think as of today it's not able to do that?
I'm not sure actually.
It actually can as of today. Um, so it's able to generate an image. So, I mean, if it were not able to do that, that's a good thing that you would want to have an agent do that. But right now, that's an example that the GPTs are able to do it anyway right now. Any other example?
Maybe multi-step. Uh,
Multi-step. Can you explain?
yeah, if you want to do like, let's say, retrieve some data and then basis what data has been retrieved, you might want to uh, analyze the accuracy of it, and if it's not accurate, do some XYZ, so on. So if there is an end goal that you have, but you don't know all the steps along the way, then each of these steps could be hopefully an
Like, can you
agent.
give an example?
Mm,
So think of an example
that's
that you think if you were to input it into, let's say, a GPT 5.1 interface today, you're not able to get a satisfactory answer.
let's say you want to book a vacation.
Mm-hmm.
Um, so maybe you have a place you want to go to and some dates, but then you need to find transportation, you need to find accommodation, you might need to find a car, and each of these is linked with each other. You might have some restrictions on how much you want to spend, but there are too many choices across all of them. So I'm thinking that you'll need to make some decisions, and then basis what you're able to find at each step, then you have to turn on, go back and refine the rest of the things. That's a
Yeah.
thought.
So when you have a very complex task with multiple source of information, um, it's not that like the latest GPTs or Claudes cannot handle complexity, but there's another reason where, like in the example that you mentioned, uh, if I were to ask like an LLM API to do that, what's the limitation?
I don't know what an LLM API would look like, right? I don't know if how it recurses between um, steps and takes the input of one and goes back. So I thought like most of the prompts I've seen have largely been forward movements.
Yeah. So if an LLM doesn't have any agents running on its, by default, the LLM itself doesn't have any current information on prices. It doesn't have any current information stored for it to respond on. So the information that it has is more uh, of like a broader understanding of a wide variety of topics and maybe even facts that historically stand true, but prices don't historically stand true. For between, let's say, I want to travel between two cities, I can't use any historical pricing for responding today. So current information is one use case where you simply cannot, uh, you know, get a direct response from an LLM. Uh, so there's definitely the time element where there is like recency, more current information, and there's also the complexity of the query and the task that needs to be broken down. And even if you break it down, maybe you can't just like respond in one shot. You might have to analyze and then go through a couple of iterations before you say, okay, I looked at this information, I got that, I got this. Now let me look at, do I need more information or am I good with this information and now I can respond? So it's gathering enough information, and that might require step by step, and also gathering current information, and which I may not, which a LLM by itself may not have access to. So it has to depend on external data sources, APIs, etc. Right? Um, so that's a good example actually, and I think we'll look at that. Arnav has something prepped exactly on that, on the travel scenario. So we'll hopefully have some time to look at that. Um, Cool. I think there's some people joining as we speak. Or no, yeah. I hope you're able to let them in. Okay, cool. So here's some examples. Given a topic, summarize the news on a particular topic in the past 1 month. Assume that there are multiple news APIs to choose from, depending on the topic, and you want to summarize news, collecting news from different APIs, and uh, maybe you also want to apply some filters. You might want to so do a bunch of other things before you respond. So when there's like no single source and you have to actually extract information from different sources, uh, that's one example. But this is still a very simple example. You might still be able to get away with with calling maybe a aggregator, um, but you'll still have to make a call to that API that an LLM doesn't have access to. Um, so when not to use agents, when the task can be subsumed into a single LLM call with an appropriate prompt and a context, and or you can retrieve through a RAG, then there's simply no need to use an agent, because an agent actually incurs extra cost. You might have to iterate multiple times and sift through a bunch of information. If it's unnecessary, then don't use agents. But if it's something like you have to make a booking and you have to evaluate the pros and cons, or you need to get like current information through news or something in a very complicated way, or do some very complicated tasks, um, maybe you want to have an agent to issue a refund to a customer, and then it has to examine all kinds of use cases before it says, okay, now you're eligible for a refund, and then I'll refund you. um, so that's another use case for an agent. um, but yeah, if you can just call an LLM directly with a prompt that's crafted for a specific task, then there's no need for an agent. So like for example, sticking to news, if you say given a topic, summarize a news on a topic that's in the past 1 month from a specific news API, there's only one API. I can just get the response from that API and then respond. Then maybe I don't really need to set up a whole agent infrastructure for this, because it's a really simple task. Um, so types of agents, you can have agents by different modalities like data agents, action agents, orchestration agents. Um, Data agents are more for agents to sift through data, understand, assimilate, analyze, retrieve insights from data. Action agents are like the one that sort of mentioned earlier, like you need to make a booking, you need to actually take actions, and these can be more like there may be more involved design for action agents, because once you take an action, there's consequences. So if you're relying on agents to take actions, you really need to make sure that it follows the guidelines uh, that are provided, by the business, or for whatever you're building that agent, it's following those guidelines properly, and it's not going overboard. So action agents can be done, but require a lot of um, guardrails and setup. Orchestration agents, and this orchestration agents come up in the context of multi-agents. Like if you have many agents, you're like, who's the boss? Who's the leader? Who's orchestrating? So that's where a master agent or an orchestration agent can come in and direct the query or piece of information to different agents. Imagine you have tons of agents, like you have an ecosystem of 50 agents that are ready to answer questions, and then the orchestration agent is able to maybe orchestrate back and forth between different agents. And so that'd be an orchestration agent. By application, you can have agents for coding. How many of us have used any coding agents in our work or in your pet projects? Like if you've used Cursor or Claude or GitHub Copilot, um, you're basically looking like, and then there are coding agents that can actually sift through whole code bases, um, uh, push a bunch of code, and do a bunch of things, and execute a whole project. And they require multiple steps, and each step depends on the result of the previous step. Um, and some steps might fail, so you have to retry and things like that.
So like, but even when we use the LLMs, right? Like, oh, sorry, the notebook on Collab, right? Even Gemini, is that considered a coding agent or not?
Gemini on Collab?
Yeah. So like when we do these things, if you just write a comment, it will actually write the code, all the code beneath it.
Oh, yeah, yeah, yeah. Yes, you can say there is a inherent agent working there as a co-pilot. That's actually looking at the context and then understanding what's already been done and then responding to you there. So there is some kind of an agent working in the background for sure. Um, and if, like, I think, let me think about this. Uh, like Copilot is a good example too, because when you say, hey, if you're using GitHub Copilot, for example, you say, hey, can you tell me if this looks good? Then it might actually retrieve different data sources or code snippets from different places and then piece together a solution and say, well, I think this is what it looks like. So every response might have it do agent kind of a work of sifting through different data sources and responding. So that's another example of an agent there. Okay, then you can have agents for different domains like weather. You can have agents for fintech. Actually, your mini project 3, if you've got a chance to take a look, is actually a fintech agent where you can ask different. You can pretty much ask a lot of complicated questions on stocks and where to invest and how to invest, and you might get very interesting answers and responses from the agent that you're going to develop for mini project 3. So fintech agents to help you with investments. So you can have agents by different applications. Um, Also by complexity, right? Again, we're just looking at categorizing agents by different in different modalities. So single agents and multi-agents. So, when you look at single agent and multi-agent, you say, okay, I think multi-agent is better. Yes and no. It again depends on whether, like, if a single agent can do your task, then use a single agent. If you don't need to use an agent, then don't use an agent. So simplicity is better than complexity. Like, if the problem is complex, then you probably need a more complex solution, but not necessarily, right? But you have to evaluate and see if I'm really standing to benefit with a multi-agent, then I can set up multiple agents to interact, because each agent will have its own set of tools, and then there'll be a mechanism to talk to each other. Maybe there's a master agent coordinating these. So all of that brings a lot of overhead and latency and cost and number of calls. Every time you call an agent, it's not just one call to an LLM. It might be multiple calls to an LLM. So it all adds up. If you have like 5 agents and then each of them gets called in a particular query, um, then you might incur like 10 LLM calls. So depending on your application, um, you probably may be okay with incurring 10 LLM calls for one query, or you may not. Um, so the good news with agents, right? Um, okay, here's a question for you guys. In the industry, like in businesses, let's say e-commerce businesses as a specific context, where do you think agents are used a lot or getting used a lot these days?
I would guess chat responses. What? Oh, agents, not just LLMs. I guess storefronts. It's like Amazon would use them if you ask a question about a product, right?
Um, it doesn't have to use an agent. It could be a single LLM call or with a RAG as well. Um, so an agent typically might incur multiple LLM calls. Yep, coding is definitely, so a lot of like companies are asking engineers to upgrade to coding agents and code more efficiently and quicker and get a lot of coding output in like limited amount of time. And so the coding agents would actually semi-automate a lot of the tasks and can break it down and give you the result, and then you can inspect it and then choose to do something more. Also, so this is a good point. So we have to differentiate from a business standpoint. We need to differentiate production use cases from non-production use cases. So because agents incur a lot of latency and a lot of production tasks need to be quick, like let's say you have to ask a question on Amazon, you can't be waiting for 10 LLM calls before you get a response. So there is a limitation or a budget for latency. Um, when it comes to production, you want to be very efficient and minimize the number of LLM calls, especially if someone is waiting, a customer is waiting for your response. But for search and discovery, that's more of like workflow and development uh, setup. Agents are very, very helpful because you can do search and discovery. You can have an agent say, hey, look at all these docs, look at all these other source of information, look at my tasks and tell me, give me some insights on how I can proceed or what am I missing. And then it can actually rummage different things and then look and pick apart and then come up with a interesting solution. So, so for search and discovery, when you have to gather information from different sources, examine, it's almost like you know, it's almost like it's scouting, right? It's scouting for information from different places, piecing it together, investigating it, and getting back to you. So that's kind of like an agent, investigating agent, right? So for search and discovery in development workflows, that's primarily a lot of the use case of agents in the industry. Although the production use cases are also starting to show up more. Um, sorry. Yeah, so the production use case is also starting to show more these days. But yeah, search and discovery is pretty much a lot of the use cases that we see right now in the industry. So tools to accelerate your work, like tools to get you going faster, agents are pretty helpful. Okay, so single agent systems, um, the kind of a structure is, the high level structure is you have an LLM model, the base LLM model, but that's not sufficient. You have multiple tools that you actually set up. And these tools can be methods, they can be function calls, and then those functions can be calling an API, they can be looking up a database, they can be doing some scripting. You can have different kinds of tools. So an agent typically comes with multiple tools. It doesn't come with single tool. Usually you say, okay, I'm an agent, I have multiple tools at my disposal. That's usually how it's set up. And there are instructions for each tool. There is probably a schema for each tool on how to use the tool, or what's the function name, what's the function name associated with the tool, what are the arguments that it takes, what's the input look like, what's the output look like. So give some schema and instructions for each tool and set up the tools in that way. And there's also a looping component because as we spoke about earlier, I guess I didn't mention it here, but the idea of an agent is plan, execute, reflect, and iterate, right? So you plan what you want to do. Like, you look at a query, say, hey, what's the weather like in Seattle, like today? And what's the forecast like tomorrow? So you look at this kind of a query and then say, well, I need to maybe call a weather API. I need to figure out where Seattle is. Maybe I get its latitude and longitude, and then I can use that to get the weather. So maybe I need to use two APIs, one to figure out the latitude, longitude, and then one to actually get the weather for a given latitude and longitude. Okay, so now the planning part is to actually construct these commands or issue these commands to these two APIs so that you can get the information. So that's the planning part. And then once you've planned it, you need to execute it because now you just have the commands, you don't have the information. So we execute it by actually, the agent will actually run those methods that you've already set up with those inputs that are given by the LLM, and then you execute, you get the response. Then you reflect. So you say, okay, I have the information now. Do I have enough information to respond, or do I need to again plan, execute, and reflect? So do I need to continue this loop? It might be that you execute, you call multiple tools in one shot, or it might be that you call one tool at a time. That's kind of something that the agent is deciding in every iteration of the loop. And then there's a termination criterion. When do you terminate? You can keep going on forever. So there's typically max number of iterations that you might set. Say, I don't have bandwidth more than 5 LLM calls. In the worst case, I don't want to be like taking like 2 minutes to respond to this. So I have budget for 5 LLM calls, let's say. So at the fifth LLM call, whatever information you have already gathered, use that to respond, right? No more gathering information after 5 LLM calls. So you might want to set a budget, or you might want to have a termination criteria and say, okay, now I'm done. Now I can respond. Okay. So that's a single agent. Um, and then multi-agent is like you have many such single agents, and then there's instructions for each agent, and then each agent has its own tools. And then there is like this idea of handing off tasks between agents. Like you might start with a master agent, and then the master agent says, okay, weather agent, give me the weather information. Okay, pricing agent, give me the pricing information. Maybe I have some other agent, whatever, safety agent, give me the safety, look up any accidents that have happened, anything I need to be concerned about. Okay, I have safety, I have weather, I have pricing. Okay, now can you tell me the top 5 destinations I can go to based on my comfort? I need something warm. So I have called upon all these agents, gathered all the information, and then I can finally respond. Okay, here's the top 5 locations based on safety, based on pricing, based on the weather, and the predictions for the weather, right? So yeah, so you might have a triaging or master agent that's kind of breaking down the tasks and passing it between different agents. Or you might even have agents that can hand off tasks to the next agent and say, okay, weather agent says, I'm done. I'm handing it off to pricing agent. Pricing agent, you take over. So they can also be those kind of capabilities that are present for agents. So deployment considerations, this is something that keeps coming up again and again. Like we said, agents typically incur more latency and more cost per query than a typical LLM call, because by definition you have multiple tools and you're looking at complex queries, so you're going to incur multiple LLM calls. So these are things to keep in mind when you actually deploy agents in the wild. And if you're having like millions of queries going through agents, you have to see if that's an efficient use of agents or the cost is too much. You need to actually maybe not use agents so much, or you need to restrict its use to certain use cases. So cost, latency, accuracy, yeah. I mean, agents can be more accurate than just a single LLM call simply because they have more access to information and they have more time to analyze the information that they have gathered. It's not just like you answer in one shot. You actually get multiple iterations to decide if you have enough information or you want to gather more. So you can actually be more accurate when you use agents as compared to a direct LLM call. And then obviously privacy and complexity are other considerations. So complex queries, definitely agents are more preferred. Cool. So we spoke about where agents are used in the industry, mostly for development workflows, discovery, search and discovery, a deep understanding of the product, deep understanding of what to do, even for like summarizing documents and then like filing Jira tickets. You can have a Jira agent that's like, if I see this is happening, I'll file a Jira ticket in this scenario, or I can identify other Jira tickets that are similar to the situation that's happening. So you can have agents that automatically file, close, flag people for different tasks. So you can have agents that work, especially for the workflow, can be very, very helpful. But yeah, I mean, agents can also be used directly in production. It just has to be, more carefully thought of. Okay, cool. So let's look at an agent demo. So we have 2 presentations for today, right, or no?
Yeah, we have 2 presentations.
Okay. Okay, so we'll look at so what we'll do now is actually we have maybe a couple of agent demos. So let's go to the first one. Let's look at something where, let's say you had to build agent from scratch. So you can obviously use some tools and libraries to build it, but it's helpful to actually look at how you do it from scratch because the core logic actually comes out. And so let's look at that. So let me share my screen and then we'll just go through some code when you had to do an agent from scratch, right? Without having to depend on a library. Of course, you don't want to do that in practice because it might be buggy, it might be hacky, it might not be extensible. There may be other issues of developing your own library, and then there's also reusability, so you might want to reuse libraries. But the purpose of us going through this code right now from scratch is just to understand the logic better. So that's a reason to implement an agent by yourself, is to understand things better. Okay, so let me share my screen. And then we'll go through some code. Okay. Okay, so I have a few files here. Let's look at, I have an LLM API call. So that's one. I have a very simple agent implementation. That's not really an agent implementation, but it's like getting started and you see how the building blocks come into play. Then we have a more involved agent implementation, and then we also will look at demo, and there's some agent tools as well. Okay, so LLM API, let's say I have to use OpenAI, and this is just setting it up as an LLM class, and there's some embeddings here. We'll ignore this, but it's just actually having access to an LLM. So I set up the OpenAI key and everything, so I'm actually able to use the LLM. So there's nothing new here. Very simple. We'll use a get completion method, and this is just the base LLM. So this is my base LLM part of the agent, is this class here. Let's look at the simplest version of the agent. So simplest version um, is where you actually hard code everything. You ask a question and say, here's the answer, right? What's the weather agent? I call the weather agent and say, okay, weather in Seattle is cloudy and temperature 58 degrees. So it's very canned. Obviously, you would replace this by some API calls, but we just have a really, really simple implementation here.
So are you showing some code here?
Are you guys not able to see?
Just able to see your prompt, not the code.
Anyone else not able to see?
I was just saying, yeah, just the terminal. There we
Yeah, you
go.
see the terminal, right?
No, I see the code now.
Oh, you were not seeing the code
Now,
before.
we were not seeing it before.
Oh, okay. Sorry about that. Okay, let's go through that again. So this is an LLM API class, right? Nothing fancy here, using OpenAI and maybe GPT-4o mini here for completion. So we use a get completion method. So this is something you guys have done, dusted, nothing new to look at here, but this is the base LLM that I'm going to use in the agent. And we'll look at a very simple agent construction. So let's say I had to develop a weather agent, and I had a question answer, like I can do multi-turns, let's say. And each turn I have to look at whether it's what's the intent of the user and then respond based on that. So here the agent responses are hard coded, so this is not what we would usually do, but this is like the simplest version, right? Where you just hard code everything. You have a thank you, you have a greeting, you have a weather, and then you get the same canned response. But we'd replace these by API calls, and then these ones would be replaced by the LLM itself responding. So when we actually implement the next version of the agent. Okay, let's actually run this simplest agent to see how it looks like and what's missing here. Agent simplest. Oh, No module. Um, mm, okay, source. Okay. Hopefully it works now. Okay, great. So enter your query. Let's say I say hi. So here the agents, so I've set it up in a way where it's actually detecting something, but all of this is hard coded, so nothing fancy here. But a real implementation would be looking at detecting an intent and then respond. So agent responds hi, then say, what's the weather in Seattle? It says weather in Seattle is currently cloudy, and then it terminates because it's a weather agent. Once it responds to a weather question, it terminates. Um, so what have we done here? Nothing much, but we've had kind of set up like really templated responses for weather, thank you, and greeting. And we are doing this based on intent. So this is running through a loop, but it's actually running through a loop to respond to every single query. So I wouldn't even call it an agent, right? This is just trying to respond and engage a customer or engage a user better, but there's no agentic stuff actually happening in this code. So let's go to the next one, LLM Agent Simple. So this is more like an agent. Um, so you can ignore all of these. These are all canned responses, so we're not going to use that. But the agent, the main loop for the agent looks like this, right? So like we spoke about, we have to plan, we have to execute, and then we update the context, and then we reflect and repeat. So plan, execute, reflect is like the loop. And then like we spoke about earlier, you set some max number of iterations, let's say 3 or 4 or 5. And then when you hit that, you say, I think we're done, just terminate and return the response that you know best. And that'll be the response that you'll show to the user. Um, so because we're building a weather agent and we spoke about latitude, longitude, and we spoke about getting location for a city, so I have set up some tools here to do the same. So the main tools here are get weather and get latitude, longitude. So these are based on an open, so there's this open Meteo where the APIs, you have some free APIs that can give you the weather and also the geocode. Um, and so you can actually return, the weather API returns the temperature and wind speed right now, like current temperature and wind speed. And then the latitude longitude method actually takes a city name and generates the latitude and longitude and returns that. Okay. So these are the tools that, so there's two tools that we have, offered to this weather agent. And now the main logic comes in is you ask a query like, actually let's run the agent. Maybe that's better. So you have okay, so enter your query. So let's say I say hi. Oops. There's some bugginess to this. Expecting value 1. Interesting. How can I assist you? Yeah, so there's something about formatting. Let me try a different query. Weather in Seattle. Okay, there you go. The current weather in Seattle is approximately 5.9 degrees Celsius. So you can see that it went through 2 iterations. And the first iteration, it said, let me call this function name, get latitude, longitude, and the argument I'm going to pass in Seattle. So it's generating what it's going to pass in to this tool, which is get latitude, longitude, and and then you evaluate that. So this is the execute, and then when you evaluate it, you just call the function get latitude, longitude with this argument Seattle, and so you get the latitude and longitude as this, and then the next iteration it says, now that I have this, get the weather, and the argument is the latitude and longitude. So then it goes to get weather API, passes in the latitude and longitude, and it actually gets a response. So in the response, you see that the tools is empty because it's actually done in the this is the third iteration. Actually, it's iteration 0, 1, 2. So this is actually the third iteration. In the third iteration, it says, I don't have to look up any tools because I got all the information. Here's the output. The current weather in Seattle is approximately 5.9 degrees Celsius. So that's when you terminate. When there's no more tool calls, just terminate here and then you return this as a response. Yeah, question?
Yeah, for agents, is it all so when you're like developing the head agent and you wanted to choose what tools to use, is that like pre-programmed based on so like for second s- um our second project, we had like
Yeah.
me and my team member use like conditionals based on what the one of the agents responded with. It was like, oh, is it 0 or 1? Do you use like conditionals or do you just say, okay, here's what these tools do, or do you just provide it its own the entire code base and say, okay, here's the code base. I want you to figure out what you can do with it.
Um, Typically, you provide some tools, and then there's more complex abstractions around this of like MCP servers, which we haven't gotten to yet. But you might already have a list of tools available with its functionalities and what it does. You might actually have a database of tools and ways to call those tools. And you might want to pick between different sets of tools and say, hey, you want to look up these sets of tools, you can go look those up. But typically those tools that whatever tools that are already provided, they already have a structure in place on their schema and how to use them and when they get used and what's the input and output look like. So you can definitely use existing tools. You don't have to build your own tools, uh, but but all of them come with a standard protocol on how to call them and what you would expect as a response and when you'd want to use it. But you can also build custom tools. So I think for mini project 3 we have provided you a bunch of tools, but you can use more tools. There's enough tools for you to get valuable insights, but if you want to use a different API and code in a different tool, go for it, right? But definitely to standardize for mini project 3, we have certain set of tools that we have provided and we expect you to use those. But above and beyond that, go for it. Like you can use whatever you want to use. Okay. Does that
I
answer your
thought
question?
I thought the question was maybe Quinn's question was more like, do you have like you might have a set of known tools, but what tool to use for what task?
Oh
Is
yeah.
that something you hard code or is that
Oh yeah, yeah. So
something?
that's where we are coming in here, right? So we haven't gotten to that. That's a good question. So hold on to it. That's part of the agent, right? Um, so here, for example, let's look at the. So just to summarize, we asked what's the weather in Seattle, and the agent went through three iterations, two iterations to get information from two specific tools, and third iteration to actually generate the response once it's gathered information. So that's this example, right? Now let's actually look at how this was done by the agent, and that'll hopefully answer the question you had. Is I set this up myself from scratch, but when you actually use modern LLMs, they actually have an interface where you can specify that you're using tools with the LLM, so they can start acting as agents. But let's say you have to do it from scratch. This is something like what you would want to do. So here I've coded the agent logic from scratch. It's a prompt that says, let's look at this. So the task is tasked with answering a query from a user. You're also given context from previous LLM runs with info on any tools used and the information retrieved. you have to decide on the following: if you need to use any of the available tools and what the arguments are for those, and B, if you have all the information needed and you can simply generate the response. So this is telling the LLM the prompt that you're passing in to the agent, and the agent is using this prompt. It's saying, "Hey, I have all these tools. Let me figure out which one to use by myself." Right? So the LLM is actually deciding that. We are not deciding it for the LLM. So we're not telling it, "Go look up this weather API and pass in this city Seattle," or whatever. Your query might be very complex. We're not telling it any of that. We're just saying, here are the tools. We think this might be helpful for you, and you can figure out which ones to use and what arguments to pass into those tools and how you want to call them one at a time. Or but we'll keep giving you more and more context. So the context always keeps getting added after every call, right? Let's say I did a first call, first iteration of the agent. I get some response. Let's say I got the latitude and longitude. You pass that back in as context to the next LLM call along with the query. So the context keeps getting appended. So the LLM knows what's already been done, and it also has the information from what's already executed, and then it can plan for its next thing. But the freedom to choose tools is on the agent, right? And that's using its natural intelligence on. It's already been trained. It's a language model. It understands stuff. You're giving it context. So that kind of becomes more like an in-context learning setup on which tools to use and how.
Yeah. Is it dangerous to throw the actual code into the tools prompt? Because like, let's say I like dynamically took the code as like actual text. So that way, whenever I change the code's output, it can like dynamically know that it's changed whenever I rerun the large language model. So I don't have to change like what the returns are. For example, something like that. Is it dangerous to put that in the tool prompt because it might just misinterpret what it's trying to do?
Yeah, yeah. So this is more like, a more hacky and uh, a scrappy way of doing this. For your actual mini project, you actually use a tool schema, and those can come with, there are more uh, ways to do it in a safer way than actually execute this directly, right? So, um, but but to your question, like, can you give an example where it's actually dangerous? I'm not fully seeing the use case.
Like, okay, so like if I were to take a long function that's because right here you just give it a single sentence where you say, hey, get latitude, longitude with arguments as city name. But instead of just saying like a single sentence, I actually just gave it the code straight up, like a 200
Uh-huh.
line function. So it
Uh-huh.
could like read the what the function does and then understand what it's like getting as a response or what the code is doing.
Okay.
Um, is it a good idea to do that ever, or is that
You're
not
saying,
is
but that's already happening, right? Like with Cursor and other coding agents, they have access to the whole code base anyway. It just depends on whether your code itself is safe or sensitive, and you want to expose it to these agents or not. If so, there'll always be privacy guardrails around what code you can use in what contexts, but you know, like large agents actually look at a whole bunch of code base, so they do that already. Um, but the
okay.
privacy, sorry, yeah. So are you asking, is your question on safety around how you pass in the information, or is it about exposing a code base or a set of
Well,
files?
I was just wondering about like so for this example, you provide the one sentence, which is very like simplistic. So the result that you're getting out of it is like the large language model could easily comprehend what it's attempting to get out and what it's putting in. Um, is it better to provide like a nuanced, like the whole function as code itself, where the large language model can understand exactly what the code is doing versus just saying, okay, here's this function name, and this is what it
Yeah.
passes back.
Well, that again, privacy comes in there, right? So, do you want to expose a whole function? Maybe it's a private code base, or you just want to expose a function name and arguments. You don't want to expose the code. So, privacy considerations will decide whether you actually want to share it. Also, it becomes very cumbersome. If I can just execute the function locally, why would I want to expose the whole code to the I might just want to tell the agent what the function does and what the purpose of that function is. But why would I want to expose the whole code to the agent when it knows what the purpose is, right? So, so then it'd be like imagine having a bunch of tools and a whole bunch of code just thrown into the context. That's just too much of overload, right? So we want to keep it structured and as much as needed. So cool. Um, yeah, so I think that's why there are tool schemas and there's like so we haven't covered that yet, but there is like standard ways of operating the tools is you specify the tool schema and then you say what tools schemas that you're using and what tools you're using and what are the tool names, and that's kind of the standard way to work with LLMs, is to just pass in those things and then it will pick on what tools to use and what arguments to pass into those tools. Okay. And so this is something, yeah. So when you actually implement in many project, you don't have to do all of this because you'll be working with an LLM that where you can enable the tools, but you'll have to definitely implement the iteration of planning, execution, and updating the context, right? Um, this is something I just did so that it's easy to like break down and see where things might go wrong. Uh, but here, for example, if we had to do all of this from scratch, then you have like a prompt for the tools. What are the tools at disposal? What's the task that the agent is supposed to implement? And then there's this final prompt that puts together the tools prompt, the context that you already had from before, the user query that's actually being asked, and then you say, well, maybe return just a JSON string because I can parse a JSON and then I can actually execute the tools and the commands in there. And then that's kind of like how this is set up. So, so when you run the agent, we actually get the tools prompt that we set up earlier. And then this gives us the set of tools to run as a JSON string. And then you can load the JSON string as a JSON code, and then you can extract with the tools and the commands from there, and you can actually execute it, right? So this is something I might want to do locally. I don't want to use an LLM to do it. I want to do it myself because I have all the tools at my disposal. And then I get the context from the output of this, and I append it, and then I reflect again. So now that I've added the context, I have more context on what I've already gathered. I reflect by repeating and looping through, and then I stop when I'm done, right? So this is what we saw earlier in this example of, yeah. So I think the previous query failed because there's something about the JSON string not being in the right format. But there's some bugginess, hackiness to this code that the format of the response here has to be in a JSON. And if it is not exactly that way, then you can throw some errors, but that's easy to fix. Um, so yeah, so this is an example of a weather agent with two tools that we used, and then you'll get to implement something like this, but in a fintech, and you can use multiple agents and multiple tools, and there's a lot of benchmarking that can be done in Mini Project 3. So you can know when you're doing well, and you can actually see there's like a lot of complex queries you can answer when you have enough number of tools and context. You can actually answer very complex queries and get some real insights, and that'd be something you can explore with Mini Project 3. By the way, I think Mini Project 3, on that note, will be working in teams of two. So, uh, and also your final presentation will be in teams of two. Even if you work by yourself, let's say for Mini Project 2, you'll have to find someone else to partner with for Mini Project, for the final presentation, because we really have limited slots and we cannot have single person presentations. It has to be a team presentation. So either present with your team member from Mini Project 2 or 3, or find someone you can partner with and present with them. Okay. So Arnav, do we have the team sheet for Mini Project 3 circulated?
Not yet. I can send it right after. I wasn't sure if we should have one for both the final project and MP3 or separate sign-up sheets for each of them.
Uh, Maybe separate is better. Let's do
Okay.
separate because people might have teamed up in mini project 2. I don't know if people are teaming up the same way for mini project 3 and for the final presentation. So, but yeah, I
Okay.
think since we've already released it, maybe we can share that, right after class.
Yeah, sounds good.
Okay. Any other questions on this, on the code or on this single agent we looked at? Okay, let's open actually. And also for your mini project, you'll do something like this, where you can actually run a Streamlit. So whatever you do, you can actually, let me just share my screen again here.